Hello and welcome back. In this video we're going to begin our playlist on quadratic functions. And before we begin our discussion of quadratic functions, I first want to review what a linear function is because I feel it will help us get a better understanding of how quadratic functions are different. So we recall that with linear functions there are four operations that you're allowed to do to x. You're allowed to add a number to x, subtract a number from x, multiply a number by x, and divide x by a number. Those were the four operations that you were allowed to do. So in these examples, we add 3 to x, we subtract 2 from x, we multiply x by 5, and we divide x by 4. So all of these functions are examples of linear functions because we are using one of the four operations. And again, we're allowed to do more than one operation. So for example, y is equal to 5x plus 2 is a linear function. In this case we are multiplying x by 5 and adding 12, so we're using addition and multiplication. That's perfectly fine. In the next example we have x divided by 5 minus 2. Here we're dividing x by 5 and then subtracting 2, so we're using the operations of subtraction and division. And finally, y is equal to negative 3x plus 8 is another example of a linear function. In this case, we're multiplying x by negative 3 and then adding 8. In this case, we're using addition and multiplication. And again, we're allowed to use those operations. So what's different about quadratic functions? Well, with quadratic functions, you're allowed to do one more operation on x. And that is, you're allowed to square x. So just as a reminder, when we square something, we mean to multiply it by itself. So x squared is equal to x times x, 3 squared is equal to 3 times 3, and 5 squared is equal to 5 times 5. So in all those examples, we're basically multiplying the number by itself. Other than that, we're allowed to do the four different operations. So we're allowed to add a number, subtract a number, multiply, and divide. So here we add 3 to x squared, we subtract 2 from x squared, we multiply x squared by 5, and we divide x squared by 4. So as long as we square x and stick to those four operations, we'll have a quadratic function. And I want to make it clear that in order for it to be a quadratic function, we have to square x. All the other four operations are optional, but we need to square x for it to qualify as a quadratic function. Once again, we're allowed to do more than one operation at once. And I also want to point out that you're still allowed to include an x term. Okay? That's also very important. So let's look at this example over here. We have y is equal to 5x squared plus 2x minus 3. Here we're multiplying x squared by 5, and we're subtracting 3. So we're using the operations of multiplication and subtraction. And we're including an x term. In this case, we're including 2x. Okay, and then y is equal to negative 3x squared plus 5x plus 8, again, is a quadratic function. In this case, we're multiplying x squared by negative 3 and adding 8, so we're using the operations of multiplication and addition. And we're including an x term. In this case, we're including 5x. So now what we're going to do is go over a whole bunch of functions, and we're going to decide whether those functions are quadratic functions. So with this first example, we have y is equal to 2x squared minus 5. Now that is a quadratic function. We have our x squared term. We're allowed to multiply by 2, and we're allowed to subtract 5. So in this case, we're using multiplication and subtraction. So that works. Y is equal to 2x plus 3 does not work because we don't have an x squared term. Remember, we said the function has to have an x squared term for it to be a quadratic function. In this case, you might have recognized that it is actually a linear function, but it is not a quadratic function. Y is equal to 8x is not a quadratic function. We don't have an x squared term, and in fact this is an exponential because the x is in the exponent, but that is something we're going to worry about later. For now, we're just going to leave that alone. Y is equal to x squared divided by 4 minus 5 is a quadratic function. we are allowed to use division and subtraction, and of course we have our x squared term. And finally, y is equal to 2x squared plus x minus 3 is a quadratic function. We have our x squared term. We're allowed to multiply it by 2. We're allowed to subtract 3, so we're using the operations of multiplication and subtraction. And we're allowed to include an x term. So that works as well. Okay, so the last thing I want to go over is something called standard form. So when we had linear functions, we had standard form and point slope form. So we had different forms of the equations that had different purposes. So same idea here, we have different forms for quadratic functions. And in this case, all the functions that we went over, all the quadratic functions that we established in this video were standard form. So we haven't seen factored form or vertex form, which are the other two forms, but we have seen plenty of examples of standard form. So the general form for an equation in standard form is y is equal to ax squared plus bx plus c. So we use this special notation. We say a, b, and c are all elements of any real number. That simply means that they can be any number. They can be positive, negative, decimal, fraction, any type of number. The one exception is that a cannot be equal to 0. Okay? So b and c can be equal to 0, but a cannot. And that makes sense, because if a is equal to 0, we'll have 0 times x squared, which will remove the x squared term. And we said we have to have an x squared term for it to be a quadratic function. So that's the one exception that is important to know. So for y is equal to 2x squared minus 3x plus 1, that is a quadratic function in standard form. In this case we have a is equal to 2, b is equal to negative 3, and c is equal to 1. Y is equal to x squared minus 5, again is in standard form. In this case we have a is equal to 1. Right, so there isn't any number in front of the x squared, but we know it's 1, because 1 times x squared is just x squared. Okay, in this case, b is equal to 0, because we don't have an x term, so we must have 0 times x so that the x term goes away. So now we know that b is equal to 0. And finally, c is equal to negative 5. Okay, and y is equal to 8x squared plus 2x, again, is a quadratic function in standard form. In this case, we have a is equal to 8, b is equal to 2, and c is equal to 0. Because we don't have any constant at the end, so that must mean that c is equal to 0. Okay, so that's all I wanted to go over for this video. In the next video, we'll be looking at what quadratic functions look like on a graph and how we can work with their different characteristics. But for now, as always, thanks for watching.